Volume of pyramids, cones, and spheres. Given the same diameter and the height for each figure, drag them to arrange in order from smallest to largest in terms of volume. Let's start there. This cylinder actually looks pretty big. Let's see, can we fit this cone inside of it? Oh, we totally can. So the cylinder is still bigger. Not sure if the sphere or the cylinder is bigger. Oh, you can actually fit the whole sphere inside of the cylinder. Okay, that's interesting. So if we take the cylinder and then rearrange them this way, it kind of looks correct in terms of smallest to largest, because this sphere doesn't have as much extra white space around it as this cone does. Notice there's a lot of extra white space going on when you put the cone inside of the cylinder. So it seems as though this is definitely the order from smallest to largest, where the cylinder is the greatest. How many filled cones do you think it would take to fill a cylinder? It's a triangle, so it might be half, or it might be a different fractional relationship. So I'm not sure how many spheres. It's definitely a whole sphere and then a little bit more. Let's see if we can find out more. Let's actually look at a demonstration when comparing the volume of cones, spheres, and cylinders. So we see that all of them are the same in terms of height, like how tall they were. So first we got a cylinder. This cone okay, he's going to pour a liquid in this. Okay, one cone in the cylinder. He's going to mark where it came up to. That's one cone. Okay, let's see if two will fill it up. Oh, two didn't fill it up. Okay, this is going to be number three. 3 cones make up the volume of an entire cylinder. So therefore the volume of a cone is 1/3 the volume of a cylinder. Okay, he's going to get rid of the liquid. Now let's see what a sphere does. Remember, when it was placed next to the cylinder and cone, they were all the same height. Okay, so there's the sphere. He's dumping it in. Let's see where it comes up to. It's past 1/3 and half. It's right at the 2/3 mark. So therefore the volume of a sphere with a set radius is equal to 2/3 the volume of a cylinder with that same radius value. And he's also showing how if you put a sphere and a cone together, you will get the volume of the cylinder. The volume of a cone is 1/3 the volume of a cylinder with the same base area, capital B, and height, h. So what would the formula for the volume of a cone be? Take a moment to pause this video to think about it, and when you're ready for the answer, unpause it. Similar to a pyramid, the volume of a cone is equal to 1/3 times the area of the base times its height. But in a cone, the base is always a circle. So we can replace the variable capital B in the formula with pi times the radius squared, because that's always the area of a circle. So that makes the revised formula for the volume of a cone to be 1/3 times pi times the radius squared times the height. And the volume of a sphere is 2/3 the volume of a cylinder with the same base area, capital B, and the height of h. If you remember from an earlier video, we saw that 3 cones were used to make the volume of a cylinder, and 2 of those cones made the volume of the sphere, and that's how we get the 2/3 times the volume of the cylinder. So take a moment to pause this video to think about the formula, and when you're done and ready for it, unpause it. Well, since the volume of a sphere is 2/3 the volume of a cylinder with the same base area and same height, we can write a formula for the volume of the sphere. It's going to be 2/3 times the volume of the cylinder, which is pi times the radius squared times the height. And if we look at our diagram, we can see that the height of the cylinder is equal to the diameter of both the cylinder and the sphere, which is equal to 2 times the radius of both the cylinder and the sphere. So if we take this 2r that we have and we substitute it in for h right here, we will get the equation that the volume of a sphere is equal to 2/3 times pi times the radius squared times 2r. Well, if we put 2r over 1 to make it easier to multiply the fractions together, we have 2 times 2, which is 4, 3 times 1, which is 3, so that'll be 4/3 as the fraction, times pi times r squared times r will be r cubed. So the final formula will be 4/3 times pi times the radius cubed. Here is an example. How much ice cream can a Friendly's waffle cone hold if it has a diameter of 3 inches and a height of 6 inches? Use 3 14/100 as the value of pi. All right, so we know that the volume of a cone is equal to 1/3 times the area of the base times the height. Well, since the area of the base is a circle, it's pi times the radius squared, so we can substitute this expression in for capital B in our formula. So we have 1/3 pi times the radius squared times the height. And now we can substitute our values in that we know. We still have the 1/3. Pi, it says in this problem to use 3 14/100. And then our radius, we don't actually have that. We're told that the diameter is 3 inches. So then the radius will be half of 3, or 3/2, which is equal to 1.5, or 1 5/10. So we can put that in. And the height is 6 inches, so 6. And then if we substitute these values into a calculator to get our solution, it'll be 1/3 times 3 14/100 times 1.5 squared times 6. So that's 14 13/100 cubic inches as our volume. And here we see that the solution calculated for the volume of the Friendly's waffle cone is 14 13/100 cubic inches. Now let's try to calculate the volume of a sphere. If the radius of a sphere is 6 5/10 centimeters, what is its volume? Well, we know that the volume formula for a sphere is 4/3 times pi times the radius cubed. So if we substitute our radius value in there, and 3 1400ths as the value of pi. We can now evaluate this expression to determine the sphere's volume. So we have 4/3 times 3 1400ths times 6 1/2 or 6 5/10 to the third power. And that's equal to 1,149 and 76/100ths about cubic centimeters. Here's the solution worked out, and the final answer for the volume, which is 1,149 and 76/100ths cubic centimeters, does match the solution that we found.